Hi, my name is Evan Fick. I represent vehicle number 1 from EFEST South and vehicle number 3 from EFEST North for South Dakota State University.
The frame of Lumberjack was nearly completed when the team lost access to the campus shop. Thankfully, a member was willing to weld the final parts of the frame at his own home. The seat was mounted more simply than originally planned, without adjustability, due to the difficulty of manufacturing the lack of shop access.
The fairing was approximately 1 week from completion when access was lost. Each of the male molds has been CNC'd and sanded. The blemishes have been coated in foam coat and 2 coats of Drivetrain. Each coat was sanded smooth before the next layer was applied. The remaining steps are to lay up fiberglass onto the molds and lay up carbon fiber inside the fiberglass molds. The team has high hopes for the finish this method will produce and still anticipates producing a full fairing for Lumberjack.
An aerodynamic parcel container was fabricated using the new fiberglass mold method to test its feasibility. The method was successful and some small lessons were learned and applied to the fairing layup, such as the importance of not oversanding before the Duratec is applied.
The drivetrain and steering components for Lumberjack were already fabricated and purchased when the team lost access to the shop. These portions of the vehicle were assembled and integrated into the bike off campus.
When the team lost access to the shop, they also lost access to the apparatus typically used to apply the required RPS testing loads. Because this testing apparatus was unavailable, a live rollover test was performed. Due to the improvised seat, the RPS test ended up being closer than anticipated. In last year's design, this test would have been impossible to perform due to the non-continuous roll hoop that required the fairing to be safe. Thankfully, this year the continuous hoop integrated into the frame keeps the rider safe even without the fairing. There was no visible deformation during or after this test.
There was no visible deformation during or after the side test either.
The vehicle has bails to keep the seat belt from sliding along the mounting bar. In previous years, a zip tie has been implemented to attempt to solve this problem.
Respirators were worn by all team members when working with the carbon fiber resin. N95 masks were worn during the sanding processes, and all team members were required to pass a shop safety exam before working. Social distancing was practiced after the COVID-19 outbreak.
This table displays the goals and actual results of the performance testing. Our goal top speed was 72 kilometers per hour, turn radius was less than 8 meters, and braking distance was 6 meters or less from 25 kilometer per hour starting speed. In actuality, we achieved a 42 kilometer per hour top speed, 3.4 meter turn radius, and a 2.2 meter stopping distance from 18 kilometers per hour.
This video shows the Lumberjack has a turn radius of 3.4 meters.
The starting speed was approximated with a Garmin GPS watch, and the stopping distance was measured from the start to finish of the braking skid mark. The brake ability was affected by the ground conditions being ice and gravel. Nonetheless, the hydraulic disc brakes functioned as designed.
The top speed was measured using a Garmin GPS watch. The top speed in this test was also affected by weather conditions, especially the freezing rain that covered the road. In better conditions, the team is optimistic that 72 kilometers per hour can be achieved.
While the fairing and seat were unable to be completed as designed, the SDSU HPVC team was able to complete an exciting and lightweight form of Lumberjack. We thank ASME for putting forth the effort to organize an online competition.